All right, so now that we know what a perfect square is, now we can actually use that to solve an equation by completing the square, now that we know how to do that. So first question you might have is, why would you do this? And the answer is you use completing the square when you can't factor something. Okay, because it's usually always easier to solve something by factoring. So here's an example. Suppose I gave you this problem right here and I said solve the following problem by factoring. Right, you could do that pretty easily. You could say what multiplies to 12 and adds to 7, and that's 4 and 3. And then you could solve that and say x equals negative 4 here, x equals negative 3. Now suppose that I change that 12 into 11. Now you can't factor it. There are no numbers that multiply to 11 and add to 7. So what do you do when you can't factor? And the answer is you use completing the square, which is what I'm going to show you right now. Okay, so how do you complete this? Well, first of all, you always have to put the equation in standard form. And just to remind you, standard form looks like this. It looks like ax squared plus bx plus c. So number one is already in standard form. We don't have to worry about that. Number two, we're going to have to do something to put it in standard form. Okay, here's the idea. Number one, this number here, 52, it's not going to factor. There are no numbers that multiply to negative 52 and add to positive 8. So this 52 is not working for us, so we'll move it over to the other side so that we can complete the square. Okay, so r squared plus 8r equals 52. I left a big space there so that we can now complete the square. So hopefully you might remember from the last time. The process for completing the square is we take half of this number, which is 4, and we square that, and we would get 16. This is now a perfect square. This is going to factor. Before we do that, though, a common mistake, people get so wrapped up in completing the square that they forget one of the most important rules of math, which is whatever you do to one side, you have to do to the other. So because I added 16 to the left, I have to do the same to the right. 52 plus 16 equals 68. Okay, this is now a perfect square, and it factors to r plus 4. Where did the 4 come from? 4 came from half of that number, and it's also what we squared to get 16. So we're almost ready to solve this. We need to solve for r, and right now r and the 4 are embedded under this squared sign. So in order to get rid of the square, think of it this way. Whatever you want to cancel out, you can do that by doing the opposite of that thing. So what's the opposite of squaring something? The opposite of squaring would be square rooting. So those will cancel. And then whatever I do to one side has to be done to the other. Okay, there's two things I have to do with the square root of 68. First of all, whenever I take the square root on this type of problem, I need to put a plus or minus in front. And here's why. Let's not use 68. I'm just going to sidebar this for a sec. Okay, let's not use 68. Let's use a number like 25. That's a little bit easier. 5 squared equals 25. But there's another thing you could square to get 25 too. You could also square negative 5. So in order to indicate that, when I'm taking the square root of 25, I don't want to only include 5 as an answer. I want to include negative 5. And the way that we do that is by using this plus or minus. So that's why I put a plus or minus there. The other thing that we need to keep in mind, and we talked about this earlier with imaginary numbers, 68, okay, let me bracket this off again, just so we have some space. 68 has one of these perfect squares inside of it. So whenever you're simplifying a square root, you always want to see, can I find one of these numbers inside? And it turns out that 4 goes into 68. 68 happens to be 4 times 17. And 4 is the square root of 4, that's the same thing as 2. Okay, so let's rewrite this a little bit. So right now we have r plus 4 equals plus or minus 2 radical 17. We're almost done. We just have one more thing to do, and that's subtract the 4. Okay, you could subtract the 4 over here, but we normally don't put it right there. We normally put it in front as a negative 4. So let me write that a little bit neater. So r is equal to negative 4 plus or minus 2 times the square root of 17. That's our final answer. It's not a nice and neat answer like you get with factoring, r equals 4, r equals 2. But that's exactly why we couldn't factor, because we're not supposed to get, in most cases, a nice, neat answer out of that. All right, let's try this second one. This is slightly more challenging because we don't have things in standard form yet. Sorry, that was not a very straight line. As you can probably tell, that's not a strong suit for me, drawing straight lines. All right, but in this case, remember, standard form is the first thing we need to do. So we need to start by putting this in standard form, which means that it equals 0. So the easiest way to make that happen is to move that over, and now that equals 0. And that means I have to add that right there as well. So negative 5a squared plus 4a squared would be negative 1a squared. Standard form means it goes a squared, and then the a term goes next. So I'm going to put that there. and then the number goes after that. Okay, this is very important. In order to complete the square, remember what I'm writing right here is standard form. In order to complete the square, this number right here has to equal 1. And if it doesn't equal 1, we need to make it equal 1. So right now, the number in front of the squared term, and I don't want to confuse you, by the way, the a here is obviously different than the a right here. We're just using a in this problem instead of x as a variable. We need that to be 1 instead of -1, so we can make that happen by multiplying everything by -1. And I'm doing the same on both sides just because we always have to do that. Okay, so -1 times 0 is 0, and then if I multiply each of these terms by -1, I would get what you see right here. -14a becomes plus 14a, -61 becomes plus 61. Okay, again, what should we do now? We should now try to finish the process of completing the square. This is not going to factor. There are no numbers that multiply to 61 and add to 14, no integers anyway. So that means the 61 is not working for us, so we'll move it over to the other side. So we get -61 equals a squared plus 14a. And then I'm going to leave a big space to complete the square. In order to do that, we need to find what is half of this number, and it turns out to be 7. And then we square that to get 49. And whatever I do to one side, I have to do the same on the other. So 49 plus -61 is -12. And then this is now a perfect square. That factors to a plus 7. Where did the 7 come from? It came from half of that number right there. Okay, so we're almost done. We just have a couple more steps to do from here. Okay, what we need to do next is we need to cancel out that squared by square rooting both sides. Okay, so those will cancel. And whatever I do to one side is same as done to the other. And then remember, put a plus or minus in front of that square root. And that's because there's two things that you could have squared to get that, the positive or the negative version of that. Okay, now here's the deal. We have a negative right there, so I'm going to split up -12 like follows. I'm going to split it up into -1 times 12. Okay, another name for that, by the way, is I, because the square root of -1 is the same as I. And then remember, we want to look for perfect squares that can come out of the numbers. So anything in this list that comes out of 12, and you can probably tell that 4 comes out of it, this is the same thing as the square root of 4 times the square root of 3. So the square root of 4, that's equal to 2. Square root of 3, we can't do anything more with. Okay, and then normally we write it as 2 times I, not I times 2. And then that's equal to a plus 7. Very last step right here is to subtract the 7 and then subtract the 7 over here. And this right here is our final answer. It's an imaginary answer, but that's okay. That does sometimes happen. Okay, so that's how you solve by completing the square. In the next video, I'm going to show you a slightly harder version. There's really only one extra step. I said that this is a harder case because in these problems right here, the a value, that means the number in front of the squared term, is not going to be equal to 1. Okay, so try these right now. See if you can make it equal 1. In the next video, I'll show you the solution.